Hello students, welcome to my YouTube channel Dear Mathematics and also welcome to the topic of limit. This is the fourth part of the topic limit. In the previous video session, we have already discussed about the substitution method and factorization method. In this particular video session, we are going to discuss about the rationalization method. So why we should discuss or why we should apply the rationalization method in the topic of limit, or what do we mean by rationalization method? So this method is used when either numerator or denominator or both involve expressions consisting of square roots. That means the problems which is based upon the square root of denominator, numerator, or both square root of numerator or denominator. In this type of problems, just we have to use the rationalization method. If we substitute the value of x in the problem, then it gives the result as 0 by 0 or infinity by infinity. So let us discuss about some of the problems based upon the rationalization method of the topic limit. So here it is the first problem. Limit x tends to 0, square root of 2 plus x minus square root of 2 divided by x. So here it is the first problem based upon the rationalization method of topic limit. If we substitute the value of x is equal to 0 here, then what we are getting here? We are getting square root of 2 plus 0 minus square root of 2 divided by the value of x is equal to 0. That means root over of 2 minus root over of 2 divided by 0, which is equal to 0 by 0, which is equal to 0 by 0, which is the indeterminate form. So we are getting here 0 by 0 form. It is in the 0 by 0 form. So by rationalizing the numerator, what we have to do? Just we have to multiply the conjugate of the numerator. Limit x tends to 0 and the conjugate is square root of 2 plus x plus square root of 2 whole divided by x multiplied with square root of 2 plus x plus square root of 2. Just we have used rationalization method. So it will become 2 plus x minus 2 divided by x multiplied with square root of 2 plus x plus square root of 2. Limit x tends to 0. Okay, by cancelling here we can get x divided by x multiplied with square root of 2 plus x minus plus square root of 2, then cancelling both of the parts here. Just we are getting here limit x tends to 0, 1 upon square root of 2 plus x plus square root of 2, and here we can put the value of x because it is not in the form of 0 by 0. And we have to use the direct substitution method. By putting 0 here, we are getting square root of 2 plus square root of 2. That means it is 1 upon 2 root 2. So here it is the answer for the problem number 1, that we have used rationalization method to solve this type of limits, where the numerator contains the square root. And whenever we are putting the value x is equal to 0 here, we are getting it is as 0 by 0, which is the indeterminate form. Now let us move towards to the problem number 2. Then let us go through the problem number 2. It is given that limit x divided by square root of a plus x minus square root of a minus x when x tends to 0. Again, the denominator contains the square root. And let us put the value of x is equal to 0 in this function. Then it will become 0 divided by a plus 0, square root of a plus 0 minus square root of a minus 0. Then it is 0 divided by square root of a minus square root of a. And again it becomes 0 by 0. And you can see that it is in the form of 0 by 0, which is the indeterminate form. So we have to use the rationalization method here. So by multiplying the conjugate of the denominator here, limiting value, limit x tends to 0, x divided by square root of a plus x minus square root of a minus x. And the conjugate of this denominator, it is square root of a plus x plus square root of a minus x. Then multiplying this term with again to the numerator also, square root of a plus x plus square root of a minus x. Limit x tends to 0, x multiplied with the square root of a plus x plus square root of a minus x divided by, then the denominator becomes a plus x minus a minus x by applying the algebraic identity a plus x into a minus x, that is a square minus b square. So it will become limit x tends to 0, x multiplied with the square root of a plus x plus square root of a minus x, then it will become a plus x minus a plus x. That means we are getting here limit x tends to 0, x multiplied with the square root of a plus x plus square root of a minus x whole divided by 2x, just cancelling the x from the numerator as well as from the denominator. We are getting here 1 by 2 is a constant, 1 by 2 limit x tends to 0, it is square root of a plus x plus square root of a minus x. Now we can put the value x is equal to 0 directly, or direct substitution method will be applied here. So it will be 1 by 2, it is square root of a plus square root of a, that means 2 square root of a divided by 2, and that is square root of a. So here it is the answer for the problem number 2. Then coming to the third problem, it is given that limit x tends to 0 of a square root of a square plus a square minus square root of a square minus x square divided by x square. Let us put the value x is equal to 0 in the given function. A square minus a square divided by 0, that means again it is 0 by 0. Again it is 0 by 0 form, that is the indeterminate form. So you have to use the rationalization method, and by rationalizing the numerator, because square root exists in the numerator part of this function. So limit x tends to 0, a square plus x square root of a square plus x square minus square root of a square minus a square root of a square plus x square plus square root of a square minus a square, and again multiplying the same conjugate term in the denominator part also, it is x square multiplying with now you have to use the algebraic identity formula in the numerator part, then it will become limit x tends to 0, it is a square plus x square minus a square minus x square whole divided by x square multiplied with square root of a square plus x square plus square root of a square minus x square. Then we have to simplify the numerator here. Limit x tends to 0, a square plus x square minus a square plus x square whole divided by x square multiplied with square root of a square plus a square plus square root of a square minus x square. Then cancelling both of the a square and minus a square, we are getting here limit x tends to 0, 2x square divided by x square multiplied with a square plus square root of a square plus x square plus square root of a square minus a square. Then cancelling both of the x square from the numerator and denominator part, we are getting 2 is the constant, so it will be taken to the outside of the process. Then it will be 2 multiplied with limit x tends to 0, 1 upon square root of a square plus x square plus square root of a square minus a square. Then just we have to put the value of x is equal to 0 here, because direct substitution method will be applied here, because if we are putting x is equal to 0 here, then it is not getting into the form of indeterminate. So it will be 2 multiplied with 1 upon it is a square plus square root of a square. That means 2 multiplied with 1 upon 1 divided by 2a square. So it will be 1 upon a, and this is the answer for the problem number, oh yeah, this is 3. Okay. Then coming to the next problem. Now let us go through the problem number 4, example number 4. Okay, here the square root exists in the denominator part. First of all, let us put the value of x is equal to 0, whether it is in the indeterminate form or not. By putting here, it is 4 square minus 16 divided by 4 square plus 9 minus 5, then it is 16 minus 16 divided by 16 plus 9 is 25. Square root of 25, it is 5 minus 5. Okay, this is again in the form of a 0 by 0. So again we have to use the rationalization method here. First of all, you have to check by putting the value of x in the given function whether it is 0 by 0 or infinity by infinity. If it is 0 by 0 or infinity by infinity form, then you have to use the rationalization method. Otherwise, you have to use the direct substitution method. Okay, it is in the 0 by 0 form by rationalizing the denominator part. So we have to find out. So we have to find out the conjugate part of the denominator, and the conjugate of the denominator is x root over of x square plus 9 plus 5. Again multiplying the same part here in the same term in the numerator part, square root of x square plus 9 plus 5, then it is limit x tends to 4 x square minus 16 multiplied the square root of x square plus 9 plus 5 divided by it is x square plus 9 minus 5 square whole square of 5, then it is limit x tends to 4 x square minus 16 square root of x square plus 9 plus 5 divided by it is x square minus 16. Then cancelling both of the common parts from the numerator and denominator, we have it is limit x tends to 4, it is square root of x square plus 9 plus 5. Then by putting the value of x is equal to 4 here, it is 16 plus 9 and it's square root plus 5, that means it is 5 plus 5. Okay, answer is equal to 10. So here we have solved the problem number 4, or you can say that example number 4. Then coming to the example number 5, which is again based upon the rationalization method. Then coming to the example number 5. Limit x tends to 1 2x minus 3 multiplied with the square root of x minus 1 divided by 2x square plus x minus 3. First of all, let us check whether it is in the indeterminate form or not. Okay, it is 2 minus 3, it is 1 minus 1 divided by 2 into 1 square plus 1 minus 3, that means it is minus 1, 0 divided by 0, that means again it is 0 by 0. So it is indeterminate form, that means we have to rationalize 0 by 0 form. Limit x tends to 1 2x minus 3 multiplied with the square root of x minus 1 whole divided by, after factorizing the denominator part, simplifying, we are getting here 2x plus 3 multiplied with the x minus 1. Limit x tends to 1, then here the square root part or the function which contains a square root exists in the numerator part. That means we have to multiply the conjugate of that function to both numerator as well as the denominator. So it will be 2x minus 3 multiplied with the square root x minus 1 divided by 2x plus 3 multiplied with x minus 1. First of all, let us multiply the conjugate. Limit x tends to 1, it is 2x minus 3 a plus b into a minus b, that means it is a square minus b square, which is x minus 1 divided by 2x plus 3, then it is x minus 1 multiplied with the square root of x plus 1. Cancelling both of the common parts here, we are getting limit x tends to 1 2x minus 3 whole divided by 2x plus 3 into square root of x plus 1. So here Again, let us check whether it is in the indeterminate form or not. No, okay, it is not in the indeterminate form. So we have to put the value x in the given function. That means we have to use the direct substitution method in the problem. So by putting the value of x is equal to 1, here it is 2 minus 3 divided by 2 plus 3 multiplied with 1 plus 1. That means it is equal to minus 1 divided by 5 into 2, and that is equal to minus 1 by 10, which is the answer for the problem number 5. Then coming to the problem number 6. So here it is the problem number 6 I have taken here. It is limit x tends to 0, square root of 1 plus x minus 1 divided by x is equal to 1 by 2, and it is the task for you. Just you have to solve it by using the concept of rationalization method. First of all, you have to check it whether it is in the indeterminate form or not. If it is in the indeterminate form 0 by 0 or infinity by infinity, then you have to rationalize it, and the square root function exists in the numerator part. That means you have to rationalize the numerator. Then you have to multiply the conjugate of the numerator or the square root function to both numerator and denominator. Then you have to solve it and simplify it and find out that the result is 1 by 2. So in this particular video session, this is the fourth part of the topic limit. This is the fourth video session. And here we have discussed about the concept of rationalization method, or the concept of using the rationalization method, where we have to use the rationalization method in the problems that are from the topic limit. In the next video session, again we are going to discuss about some more problems based upon the topic limit. Till then, thank you.